There we go. That's a little bit better. Well, thanks everybody that's here in attendance and online. Big thank you to Corinne and the ETC for hosting this event and giving Mila the opportunity to do this afternoon worth of content. I think we're in for some pretty engaging sessions. We have session number 1 will be a discussion about the use of technology for methane emission reduction. Number 2, we have the NGIF in to give us some really good updates on what they've been up to, and then we'll discuss how data can help reduce methane emissions as well. Little overview of what Mila is, who we are. We are a group comprised of service and technology providers. We have a very common goal of strengthening our valued industry through emissions reduction. I think we're fairly unique in the space, and we're comprised of some very innovative and driven members that all participate in the emissions reduction sector. This is our board of directors. We do have one of them standing right over there in the corner. I tried to get him to speak today, but he wouldn't. Lots of recognizable faces, and we've got a lot of power on this board of directors. I think there's a lot of knowledge there, and we lean on that pretty heavily for our direction, and really appreciate everything that they put into this. Now, what is Mila comprised of? Right there is what Mila's comprised of. This is our members, and this is the most valuable piece of the entire organization, because honestly, without the members, Mila doesn't exist. Our members are comprised of all service and technology companies, very, very diverse. I mean, we range from data evaluation, carbon offset generation type companies. We have research, we have LDAR services, right into the actual service providers that are out in the field, and technology and innovation providers. I think that the list up there, I think you recognize a lot of the different companies that are up there if you have anything to do with emissions reduction in Alberta and really Western Canada. And you know, huge thank you to all of our members for participating, and again, we couldn't do this without them. So one of the things that we're involved in at Mila, and I just wanted to do a very quick overview because we're pretty proud of this one, and it's very new. This just got released maybe a week ago. We did a webinar on it this morning, and that's the Government of Alberta and the ERA's Methane Reduction Deployment Program. There is $22.4 million available for methane emissions reduction in Alberta. I think, you know, what I want to stress here is that we are doing a lot. We're very active in emissions reduction in Alberta, and I think we should be very proud of where we are at, where we've come from, but you know, also recognizing that we can also strive to do more. And I think, you know, by the Alberta government putting out this kind of funding and some of the funding that NGIF is going to talk about as well, that really shows the commitment to methane emissions reduction in Alberta. You know, one of the little known facts is that we were the first jurisdiction in North America to set a methane emissions reduction target. I think there's a lot of firsts that we don't necessarily talk about when it comes to emissions reduction in Alberta, and it's just something that we should be very, very proud of, and I know as a proud Albertan that I am extremely proud of what we're doing. Mila's role in this is to help with the business development and industry outreach side, so I hope that anybody online or in person here that wants to discuss the program further, get a hold of me. I'm happy to talk about it. That's what I'm doing, and one of our members, Modern West Advisory, are actually delivering the program along with ERA. So, you know, lots of involvement there, and very, very proud again to be involved in that. It is a $22.4 million project, covering up to 50% of eligible costs on emissions reduction projects, up to $1 million per project, and also $1 million per participant or parent company. So if you're an oil company, you can get up to $1 million of funding, which is essentially a $2 million project when you look at 50% funding. So please get a hold of me about this. Take a look online, go to ERA's website. I think it's something that we should be very proud of and participating in. Again, just a list of our members. I just really want to stress that I'm very proud to work with every single one of these companies. I really want to support them and show what they can do, because I think as an industry, again, we should be very proud of what we're doing in Alberta. The innovation here and the expertise that we have isn't just for the oil field in Alberta either. We can look at exports. We can look at at sending to places like the Middle East. We can look at Africa. We can look at all of these different oil producing countries, but we can also look at Eastern Canada and use over there. The technology and the services translate directly to all oil and gas. And one of the things that I'm very adamant about is that the technology that's produced here is some of the most robust in the world, because we have to not only design it for use in heat, which we get, plus 40 degrees Celsius at times. We also have to design it for minus 40 or below. I know the coldest that I ever worked in on a well site was minus 56. So if technology can work there, it can work just about anywhere. So again, thank you to all of our members. Really appreciate everything that you do. And that's my contact info. There's also a QR code that you can scan. You can go to the MELA website and take a look at what we do. Please get a hold of me anytime if you have any questions, whether it's just about the organization or if it's about the methane reduction deployment program. So now we're going to get on to the good stuff, into some discussions. So the first one that we're going to talk here is technology-based solutions for methane emissions reduction. We're going to bring up Steve Froehler, president of LCO Technologies. So this will be deck number 2. And Steve's going to give you an overview, and then we're going to follow with a couple more and then some questions. So if you do have any questions, please log them till the end, and we'll go from there. Thank you very much.
Hello, everyone. Thank you for the opportunity to talk today. I'm Steve Froehler. I'm the owner of LCO Technologies and the inventor of that piece of equipment right there. This happened to me the last time I was up here. I think I need somebody smarter than me to... here we are. So LCO Technologies, that's me. Been at it for 30 years, been working on the Crossfire for about the last 8. Here's an example of, okay, I was asked to do this on an educational basis, and I'm sorry, I'm going to apologize right now for everyone in the room, because I think everyone here, everyone understands how we've taken this journey in Alberta to reduce our methane emissions by 52%. But there are a lot of people apparently online that are watching this who don't understand how we've done it. And frankly, I'm astonished at times just talking to people when I go to various events, especially back east, when we say, are you even aware of the fact that we've done this? And the answer is no. So I'm very happy to be here to reinforce the fact that, we're kind of killing it out here, and I'm happy to say that LCO Technologies has made a fairly decent contribution to that effort. But this all started back after 2014, when the industry took a look at where the methane venting was coming from in the field, in conventional upstream oil and gas. And when you look at a producer who has to put a well in a remote location where there's no power, what they'll do is they'll take a small amount of gas from the well and they'll condition it on site. So they knock out the water and the sand. Now they've got clean methane, or clean gas. It is rarely ever just pure methane. But they've got this clean gas that they can use like air in a garage where you would use an air gun to take off a tire. But in this case, what we're doing is we're using this gas as a means of being able to manipulate instrumentation. So we're using it to control pressure, level, flow, and drive pneumatic-powered chemical injection pumps. The naughty bit is after we finish exploiting the pressure, we then vent that gas to the atmosphere. So part of the problem that we have with well, first of all, we have this methane that's being vented to the atmosphere. And now, a lot of this oil and gas bearing territory happens to be significantly north of Calgary. So in the dead of winter, when you only have 4 hours of daylight, and you're trying to exploit solar power perhaps as a means of being able to use solar power to drive electric versions of this pneumatic instrumentation, it becomes difficult because 4 hours of daylight doesn't give you a whole lot of juice. So it became incumbent upon us as manufacturers to try and develop technology that can be deployed north of Edmonton and be reliable. Now, and we've done it. I mean, Doug's here, he's going to talk about CalScan. They've done a great job on these super low energy consuming electric actuators. We have an air compressor over here that can produce enough air to be able to run a couple of wells, and we run that on less power than a 100-watt light bulb. These are significant improvements in efficiency and technology that allow us to be able to address a couple of key areas. One of them is pneumatic instrumentation that would normally use methane and vent methane into the environment versus using air where you'd be venting air into the environment. Okay? It had been tried 1,000 times and it had failed 1,000 times, and we managed to pull it off. So good for us. Now we're deploying. This site, for example, this is a site that's very interesting. It's full of pneumatic instrumentation, okay? But the one thing you won't see on this site is a fuel gas separator. This site does not have fuel gas or utility gas on it. We're running it on air, and we're running it on power from solar panels and fuel cells. That's a decent-sized skid. So here we've got 3 examples of the equipment. We've got an air compressor, a chemical injection pump, and a vapor recovery unit. Okay? These are the 3 key areas from conventional upstream oil and gas, conventional oil and gas that emit quite a lot of gas into the environment. And we have solutions for these, but it's not as straightforward as, I make it sound super easy. We just take air and take a compressor, we run it on solar, problem solved. It's not that easy. It started with taking high bleed relays that were in all that instrumentation. You saw that skid that we showed you earlier. I don't know how many relays were in that unit, but they started off with what were called high bleed relays. Okay, and the industry saw an opportunity to significantly reduce their carbon footprint or the amount of methane gas that they were venting by simply changing these relays from high bleed to low bleed. Great. Okay, so you've reduced your methane output by, how much was that, Blake? About 5 to 8%, or 5 to 8 times. So in some cases, you were getting down to 1/8 of the original amount of gas that was being vented to the atmosphere, but you're still venting. Okay, it's better, but not quite perfect. But it was a really, really great way to try and to significantly reduce the carbon intensity of conventional oil and gas. Okay, so that was the lowest hanging fruit. The next lowest hanging fruit was chemical injection pumps. Okay, pneumatic chemical injection pumps emit, in many cases, they can emit more gas than the instrumentation. But the solution associated with solving that was a higher expense. Okay, so it became the next on the list of priorities. And now we have chemical injection pumps that can replace, in this case, with ours, we can replace 4 pneumatic chemical injection pumps with 1 solar-powered pump. Okay, so when you look at the most common type of pneumatic chemical injection pump in the field, it can emit north of 140 tons a year if you're driving it like a maniac. Okay, if you're stroking that thing at 33 to 35 strokes a minute, it's 140 tons a year if you've got a high concentration of methane. Okay, it's generally speaking, the average was about 70 tons. Oh, just 70 tons. Pretty worthwhile trying to resolve. Okay, and if I can replace 4 of those with 1 pump, I think we're making some pretty significant strides forward. Now, the last area is when the oil and gas comes out of the ground, it goes through what's called a separator. Okay, so we separate the oil from the gas, and it goes into storage tanks. In a lot of cases, not all the time, most of the time it doesn't, but there's still thousands of these tanks that you'll see out in a farmer's field, not in a farmer's field. You'll see tanks in a farmer's field, and quite often you'll see this little pipe out of the top that's got a little gooseneck on it. We call that a gooseneck. It's a 180-degree turn and is open to the atmosphere. When the oil is separated from the water, what happens is it goes into the tank and gas literally foams out of the water and escapes from that little piece of pipe that's on the top of the tank. Well, how are we going to stop that? Okay, we use what's called a vapor recovery unit. Okay, we've successfully deployed these vapor recovery units, but unfortunately, it becomes a very complex application. Okay, there's a low tolerance for risk with respect to protecting the tanks. So when you take an open tank and suddenly you close it and you put on this VRU, which is like a vacuum for the vapor inside the tank, what's going to stop that tank from imploding? Okay, and the steps that you're willing to take, or the steps that you feel it's necessary to take, can define the cost associated with deploying the equipment. My equipment is low cost, barely $10,000. Okay, but the ancillary equipment associated with trying to deploy it becomes excessive. Okay, so we have some issues. Okay, and we have some ideas, and I think we'll get there. So now we're dealing with the instrumentation, the chemical injection pumps, and the vapor from the tanks. Basically, everything else out there is flares and unintended vents, for the most part, with respect to conventional oil and gas. We're using a common platform. The piece in the center is fire, or the common platform. That's an explosion-proof drive. That can be configured as either a pump, a compressor, or a VRU. So you see the section in the center here. That becomes common to all 3 pieces. The beauty of it is I can mass produce it, and I can do it for less because I can mass produce it. It makes it easy for end users because now it means fewer spare parts, easier to get equipment. Okay, so ultimately our objective is to prevent methane emissions and improve efficiency. And the problem with everything that we do here, being environmental, is it's even though everyone talks a big game about wanting to protect the environment, our equipment is still considered, for the most part, just an expense. It's an expense and it's hard to justify. It's not hard to justify. It's hard to reconcile when you're talking to shareholders and things like that. Okay? What we need to do as technology developers is deliver more than just eliminating the methane emissions. We need to deliver productivity gains. We need to provide things like data. We need to provide, when you look at what we do, we drive the equipment with a microprocessor-based controller, and we're gathering data. We're giving people information. We're giving people the ability to make decisions based on data rather than making decisions based on routine. So is there a benefit to this? I'd say yes, there is. Instead of an operator going out to a site because that's what they always do, They can go out to a site based on there being some sort of exception that can be conveyed to them through data that they acquire through the equipment. So it's not just environmental improvement, it's operational efficiency gains. Okay, if we can't as a group deliver that, I mean, I'm not counting on Alberta Environment to make my business plan. I need to have something that I know is palatable for more than just the fact that we're doing something to help with the emissions. And I think we've done that. On the chemical injection pump, doing things like accurately controlling the delivery of the chemical. Hit your chemical budget spot on every month. That's money in your pocket. That's ROI. And now I'm about to start pedaling, so I'm going to just say thank you very much for your time and appreciate it. Thank you. If there's any questions, anyone?
Yeah, we'll do questions.
Oh, okay. This thing is a bit of a pain in the ass. Thanks.
All right, thanks, Steve. Hand talkers and podium mics. It doesn't usually work together. Next up, I'll bring up Doug Baspalko from CalScan to do his presentation.
Good afternoon, everybody. Merry Christmas for those who've already started shopping. Oh, by the way, it's Sunlight Friday, it's Black Friday tomorrow, I guess. So, and happy Thanksgiving to our American friends as well, I guess today is, so football is on. My name is Doug Baspalko. Let's just keep it at Doug. I'm the technical sales manager for CalScan. For those of you who don't know, CalScan is a Canadian Alberta company headquartered in Edmonton. We are the manufacturers as well of the technology that I'm about to present to you at a very high level. We approached the methane mitigation journey from a bit of a different angle. Steve brought up some very good points about the emissions challenge. We decided to go the solar route. So imagine operating your well sites with solar power. How many of you adjust a thermostat in your house for the heat? Gas comes on, it's all electric. It's simple. So we've been able to simplify this, and again, we approached it from an efficiency point of view. Whenever you're efficient doing something, you're automatically saving energy, you're saving emissions. Okay, now let's go to the next slide. So these are some of the achievements we've already done with our solar power, and I'll get into that a little further. I mean, major operational and regulatory challenges because of the new regs that are coming in. And everybody, of course, wants to operate efficiently. Currently, to date, we're approximately 400,000 tons of CO2 equivalent that we have saved with our technology. We've also increased uptime, we've reduced maintenance, and lowered OPEX. One of my colleagues who works for a company said, if it rotates, it's a problem. So we've brought producers to the 20th century. This is a picture of a well that we run off solar. We've eliminated the emissions that they had controlling it. So where I want to show you is this is no longer theoretical. This is real world technology that's being implemented. So CalScan started their journey in 2010. A producer came to us with operational problems, struggles, no utilities out in the middle of nowhere, using, like Steve pointed out, fuel gas and pneumatics, and wanted to reduce his costs and eliminate a lot of it. So we started our journey in 2010 by delivering solar-powered valve actuation. Just like your thermostat in your house, when you turn it to go high, the gas valve opens. So that's a little electric valve. So we started in 2010, and then by 2012, we are already deploying it for several sites. The question we get asked is, does it work in the north? We currently have several hundred sites operating in northern BC and northern Alberta, strictly on solar, and a majority of them running with no backup. In other words, solar panels, charging batteries that sit there and keep the operation going without any backup generator. There have been some cases where there was some skepticism where they did put a generator in there for about 6 months. But with a generator, you have to go and start it up every so often so it starts when you need it. So these are real-world sites running totally on solar, reliably, and we've proven that it's been able to run with very low sunlight. Most of the calculations up there, the minimum sunlight is 2 hours a day on a bad day, or an hour a day, but we size the systems for that. Now, along with our journey with our electric valves being efficient, to operate them, like I said, you need like a little electric motor on top or a little electric device. It's to change the way we look at the technology we've been using in valve technology for the last 40 years. If you go to some of these sites, they've been operating for 30, 40 years. And they operated very well. However, with the old technology utilized in them, it's time to improve them and optimize them for efficiencies. So to add to that, we went on a journey to develop more efficient valves to make it easier for operations, lower OPEX costs, in order to minimize the amount of maintenance that companies have to do. What you're looking at now is we've done it on several hundred sites. Very simple valves that can be installed. The same valve can be installed in different configurations, maintaining consistency. We've eliminated piping for instrument air headers. We've eliminated tubing. We've eliminated anything that rotates when it comes to our technology. It's been known to be, we've measured it, the technology to operate is less than a string of Christmas lights. We're now being approached by several international companies that have no utilities in the middle of nowhere to be able to operate their well sites. We're in test with a few of them to prove to them that they can operate. And again, there's no CD disc, there's no programming that's required for these valves. They fit right into your standard operating facilities that you need to do. So again, it is proven technology since 2010. So producers have been looking at optimizing. Producers have pushed technology to where we are at today. So here's a few facts about solar electrification as a mitigating solution. Whenever you're looking at a solution to mitigate methane, these 3 bullets are extremely important, and I can't take credit for them because they were at the PTAC summit, I believe it was 3 years ago. The guest speaker mentioned. Number 1, it has to be reliable, just like your furnace thermostat, if I can use it as an example, because it's cold outside. Secondly, is it affordable? Our technology, we've had an ROI, which is a return on investment, in less than 6 months on some of the marginal wells. In other words, a well that's barely producing, It's eliminated the operational costs, it's eliminated the maintenance costs, to the point where they got payback for our equipment in under 6 months. The last and most important thing, high environmental performance. How is the technology impacting the environment? What did it take to build the technology? What does it take to dispose of the technology? What's the cost of maintaining the technology and the environmental impact? Now, that should have been, I changed that word, I guess he didn't put it. It's not an unintended consequence. Blake didn't put it. It was supposed to be unintended benefits. The first one, we've enhanced safety. When an operator doesn't have to go to site to change the oil, to change anything, it's safer. Immediate ROI, I mentioned, payback in under 6 months. It's scalable if you want to add to it. Easy. Now, the last one is data for AI. I'm going to share a quick story with you. I was down at a conference and we were sitting around a table talking to some engineers, and one of the engineers says, you know, this is real cool. I'm going to use one of these valves to detect how many times it moves on Tuesday and on Wednesday and what my well is doing. And we said, why? He says, well, I'm going to study the effect of the moon's gravity on the oil reservoir. So we all looked over at him, never say never, and said, what's the medication you're on? So we looked at each other, and I got a shock. 2 weeks ago, I was explaining our technology to a young engineer here in Alberta, in the Bonnyville area he worked, and he said, yes, they did notice a difference in production depending upon the moon cycle, because if it can move the ocean 6 feet, what's it doing to the reservoir? Now, I like to call my geotechnical friends and engineers rock hounds. Those guys understand that stuff. I'm an instrument guy. I know nothing about anything that happens in the dirt. So from a data for AI, now we're looking at it as a live animal. So if you've got the technology that's inexpensive, reliable, meets all the environmental performance, and now you've got data for your analysts to evaluate, maybe I should pump more on Thursday instead of on Tuesday to save energy. So I'd like us all to start focusing on operational efficiency. So, and if you, sorry, yeah. So that's our contact information. Again, I'm here in Calgary. Our head office is in Edmonton here. We work across Canada, of course, and now we're reaching out internationally. So any questions or any thoughts or disagreements, I'm open to a discussion.
Thanks, Doug. I'll just put this up for me and Joe. Next up, we'll have Joe Pfaff from TCI, Total Combustion Inc.
Hello, everybody. Thanks for having us here today, and thanks, Blake, for giving us a space to talk and talk about our technology. For total combustion, what we do is enclosed combustion or incineration in the upstream and midstream oil and gas space. To start with us, we've been in business for over 25 years now. Right in the heart of Alberta. Our manufacturing facility is in Red Deer, Alberta. We've been shipping equipment worldwide since the beginning of the inception. Our major stuff that we've really started with was in and around Calgary and Sundre, and the initial part of this technology was to hide the flame so that it didn't bother any of our neighbors. But let me get into how we can actually accomplish that. We engineer these things as simple as we possibly can. High quality stainless steel stacks for life of the equipment, natural draft, so there's no power on site for fans or anything like that. We can have an ignition system that runs completely on solar. Trailer mounted and different applications for that. We have our classic series, which are typically pile mounted on a facility wherever they have any stranded gas, from 200 cubic meters a day all the way up to 110,000 cubic meters a day. Again, different ways that we move these around. We have trailer mounted units, skid mounted units, and I'm going to kind of touch on where those pieces of technology fit in. In the upstream oil and gas industry, we have various different ways that methane is vented or needs to be destroyed. One of the biggest ones that we've looked into over the past few years is vented gas from oil production tanks. One of the greatest things you can do with that is put a VRU system on it and capture that gas. That's not always economical to do if you have nowhere or no infrastructure to send this gas to on these remote sites. This is a project that we just completed. It is a tank vapors up in northern Alberta. What we've managed to do is burn or combust at 99.9% combustion efficiency 3.7 decks of gas daily. What does that actually mean for emissions reduction? That's like taking 165 cars off the road compared to venting that gas, which was previously done many years ago. Next one that we're seeing in this space is casing gas. On your low end casing gas, up to 300 cubic meters a day, it's not economical to move it into a pipeline or capture it. So the best thing that we can find to do with it is to combust it at 99.9% combustion efficiency. What that does on a small scale is 9 cars off the road. Now, but you got to look at this at a little bit higher, broader viewpoint. There's thousands of wells in Alberta, Western Canada, North America, worldwide, where casing gas is being vented where it could be burned or combusted, destroyed. After that methane gas is produced and cleaned, it needs to be transported to its clients, which is us and heating our homes and different chemical factories. So through transmission lines, they got to do routine maintenance, blow down, so they need to depressure them lines. The best way to reduce their emissions for that is cross compression. The constraints with cross compression is you are shutting down that pipeline transportation for longer periods of time than you wanted. So what we're doing is we're using cross compression, bringing that line pressure down to where it's no longer economical or feasible to move the gas anymore, and we're evacuating the pipeline through our combustion technology. What does that mean? How does that reduce emissions? This particular blowdown was 2 sections of 34-inch. It was about 12 kilometers long, I think, the one section. We did this in 70 hours, which is roughly a quarter of the time it would have taken to use cross compression. What does that actually mean? 3,400 cars off the road on one job in 70 hours. This type of work is completed throughout North America daily. Another section of it is when you're using ILIs or inline inspection tools. Sometimes the flow isn't generated enough naturally, so that they need to move the tool at a specific speeds to get the data. What we can do is we can put our incinerators or combustors on the end of the line and artificially draw that gas through the line for them to do their inspections. This particular project we did here was 173 cars off the road in a year, and this was a week-long project. And you can see throughout North America that these projects are going on weekly, daily. When you're using something like our technology, we would like to be a little bit upfront on it, knowing the whole parameters of it, gas analysis, and we kind of engineer a solution that fits within your budget and in your time frame. Why would you use TCI? Reducing downtime, zero disruptions to the public, reduced methane emissions, meeting upcoming federal regulations and reducing carbon tax payments. Flow testing new assets without affecting the network and your ESG constraints. I'm a little bit quicker than everybody else, but kind of some of the fun stuff that we've been doing is we've actually been shipping equipment and working in the Middle East on a few of their projects over there. They're actually looking at reducing their methane emissions just as much as we are. Throughout the United States and South America, they're looking at the technologies as well and how they can start producing their oil and gas at a lower emission rate. But there's definitely space for improvement for everybody and operational efficiencies. My contact information is down there at the bottom, and thank you very much.
Thank you, Joe. Last up for this session, we have Mr. Brian Van Vliet from Spartan Controls, and then it'll be followed by a bit of Q&A. So if you have any questions, please get them out there. Brian.
Thank you, Blake. Appreciate the opportunity to be able to speak to you here again today. Just a little bit of background about myself. I've been with Spartan Controls for just over 20 years now. I've been focused largely on upstream oil and gas, petrochemical, oil sands industries, and a lot of my focus has been helping industry be more efficient, help them waste less. So if there's opportunities we have to improve air quality, or if we can reduce methane emissions, improve our water use, or really just stitch these things together in the context of energy efficiency as well. There tends to be a business case for doing that. So it's really nice that we can make improvements, and if there's opportunity to do so, again, where there's kind of a compliance with ROI, it tends to be where my focus has been. Okay, so just as an overview, we heard some of the highlights of improvements that are being made. And what we see here in the top chart is some data that was published by AER, and it's in a report with the ST60B data, and you can see where some of the different sources are. So lots of opportunity to improve with those different buckets, and it really comes from those different parts of the upstream infrastructure and midstream infrastructure, and from the different sources that you see from the assets that are on the right. So there's opportunity certainly to improve, and we think that the transition to have lower carbon intensity hydrocarbon production remains very much a key focus going forward, and there's opportunity again to be continuing to improve in this way, the same as we've been leaders in the past. There's a lot of content on this slide, so I just wanted to walk you through this a little bit, kind of step by step here. When we're trying to improve the outcomes, we have to often understand what the magnitude is of the emissions that we're able to achieve. So if we are looking at an instrument air supply and we want to claim carbon offset credits, well, we really need to meter that to be able to have the register for the amount of air that's been used to displace the methane that was otherwise being used in pneumatic control loops. If we're looking at surface casing vent flow, there's lots of different metering technologies there as well. And if we're going to, again, be able to include that perhaps in an update to the vent gas reduction protocol in Alberta, again, we have to be able to quantify that if we're able to achieve an emission reduction. Maybe there's operations that are going, again, with volumes to flare. Can we optimize the volume that goes to flare? Could we reduce the amount that gets burned there? That would be, again, an opportunity for improvement. In all of this context, what we're really trying to do is, again, see if there's opportunity to have incremental reductions, even just small percentages. When you think about the quantity of the assets that are in the field, there's a significant gain that can be made just by thinking about the frequency of those events, again, in the field. If we look at what Steve had touched on, or Doug as well, there's lots of opportunity with electrification of assets. So in the top left, you see electrochemical injection pumps. We think that that still remains very much a low-hanging fruit in the industry. There's opportunity there as well, not just to reduce the methane emissions, but to be able to improve, hopefully, the chemical use that you have and make sure that it's exactly what it should be and not over-injected. So you're realizing operational savings that way. Certainly implementing instrument air is an option. You can imagine there's a lot of legacy well sites where doing a retrofit with electric actuation could be viewed as a higher cost than is reasonable or economical. Or maybe it actually makes more sense to put an air compressor at that site, and then that air compressor could be cycled to future sites as well to do that same activity and achieve those methane reductions. Certainly using instrument air, though, requires a reliable air compressor, so there's a new asset that needs to be maintained. And then you have to make sure, again, that you've got sufficient header pressure to operate the pneumatic control valves, chokes, CSDs, et cetera, at the well sites. In the maintenance of the air compressor, you got to make sure that there's sufficient power to operate it. If it's going to be on a solar system, there's a large enough battery bank, again, for the shorter days in the wintertime. And we got to make sure, too, that with instrument air, that it's properly cleaned and dried, right? So again, we want to have the highest purity if we can, but if there's moisture in there too, well, that's going to be an operational concern, certainly in the wintertime, because it could be freezing off your lines, and then a lot of your actuators are going to be unable to stroke properly, or they're going to be locked in place, or going to maybe trip, and you're going to go into its fail-safe position. So certainly using instrument air is an option, but it's depending on the reliability of that whole control loop. We think there's a lot of opportunity, as Doug had highlighted too, with electric actuation today. If we can get into electric actuation, same as chemical injection pumps, then we're moving away completely from the fuel gas pneumatics, and it has its advantages as well. And then there's a whole bunch of scope that we can improve in upstream oil and gas operations, midstream, that goes beyond what I've touched on. So if we're looking at on the images you see here, there's a bunch more in the engine scope. So Spartan has a technology that improves the air-fuel ratio, and we've seen that that's been a key enabler of energy efficiency to fuel gas use. So optimizing that often then is resulting as well in emission reductions from the stack. So if there's improvements in NOx emissions, then that helps us meet the federal multi-sector air pollutant regulations as well. So with better combustion efficiency and modulation of new fuel intake, there's opportunity to do vent gas capture. And if we can capture emissions from things like compressor packing vents, then again, we're able to run the asset, but we're using less new fuel gas to otherwise operate the engine too. If we look at the stacks of the engines too, there's opportunities for catalysts there. If that's going to be reducing NOx emissions, there's opportunity too with reducing methane slip in any combustion source. I know Steve had chatted about too the flexibility of the LCO platform with the same motor drive. If we have the heads on it that are there for vapor recovery, there would be opportunity too to collect some of the gas that could otherwise be emitted. And if we can gather it again and do work with it, then that's maybe the best approach too, to have a closed loop control system. And then we don't have to actually change out the emitting asset, because again, you're collecting the emissions that came from it. So industry's efforts to improve efficiencies at large industrial plants are also resulting in gains that provide ROI. So for example, optimized heaters, boilers, furnaces, there's performance there that can be achieved with improved safety too in that control loop. We see that there's a bunch of focus as well on quantified stack emissions with continuous emission monitoring systems, as well as predictive emission monitoring systems, if we can understand, again, the control loop better. So more common today too, we're seeing some work with motors that are replacing recip engines on compressor stations, and that's really dependent on the availability of your reliable power and how that cost of power compares again to the cost of burning fuel gas within that engine. We also see there's improvements in digital capabilities, so we're better leveraging information that's being available at the sites. This can be including mass flow sensors. There's alternatives that we can look at too with positioners as an alternative form of emission detection, and that actually is like a soft capability that's built into one of the instruments we provide. So I'm really excited to see where this decarbonization will go. It's been a journey that's been underway for quite a while already, and it's going to continue. And we want to make sure that we're continuing to put the focus on electrification, improved atmospheric tank management, carbon capture. We'll see there's going to be major investment likely in that space, and of course the increased use of production of hydrogen as part of that BTU value. So I highlighted here that there are many cost-effective ways available to tackle emission reductions, to reduce losses, and to improve efficiencies. And I think there's a lot of room, again, to go in this space. If we're continuing to patent new technologies that can achieve that impact, then we have those expertise here in Canada, and we can apply those expertise more globally. So thank you very much for the opportunity to share some of the examples and for showing how these improvements are being made every day.
So we'll get the other presenters back up. Brian's going to have some questions, but if there's any questions from the audience as well, just a reminder that the only way that everybody online can hear you is if you have the microphone. So I'll bring the mic around. If anybody does have questions, just throw your hand up. And I'll let these guys fire away.
Nice to meet you.
While I get the questions going, in the context of us having all these tools available to improve outcomes, what does the process look like? It's one thing to have the material, but do the people have the skill sets that they need to be able to implement these? And can you describe a little bit more of the how? If we're going to take this to the field, what's the process to actually make these retrofits happen?
Well, currently we're working with a lot of the local E&I companies, and we support the rural labor as well to make sure that everybody has the opportunity to learn the new technologies and to support the local producers where they're located. We train a lot of the local E&I companies and even the producers maintenance and support people to install our technology, and that's our business plan. And it's been very successful over the last 10 years.
Thanks. I would say one of the things that we need to have is recognition from the federal government that, and the feds really, that while they are asking us and getting us to improve our environmental performance, these are steps that in a lot of jurisdictions, they're not doing the same thing that we are. So we're being forced to compete against jurisdictions that have lower cost of production. I think what we need to have is a little recognition from the feds, a little more recognition from the feds that this is not an easy or a low-cost task, and all the support they can give us would be excellent.
I think the biggest thing for us would be getting the knowledge out there that there's room for improvement in a lot of areas. There's challenges and financial challenges with it, but recognizing where we want to be in 10 years from now and what we need to improve on, just looking inward at ourselves, that I think is the biggest step forward.
Thank you. So do you see a perfect outcome? I don't know, in an ideal world, where do you think we should be able to get to if this was 5 years from now? What do you think is reasonable and achievable?
I think there's a lot that's still achievable. I mean, we just have to look around at the field, a lot of sites where there's still a lot of venting going on. I think that the likelihood of success is extremely high. We seem to be getting more support from the feds. We seem to be getting more support from tech and producers. I mean, even in jurisdictions where there is no mandated requirement for them to reduce their emissions, they're basically looking at it and saying, if we can do it, we're going to do it, which is really great. Okay, if everyone had the same attitude, I think that we would be in a very, very good place right now, or we will be in 5 years. It's just winning everyone over and getting everyone to accept, get everyone on the same field and everyone pushing in the same direction. And I think that ultimately we will be successful.
Once we nail the regulations down and eliminate the confusion for the producers and turn them loose, they will do what needs to be done. However, to live in a world of uncertainty is very difficult today. So that's the key step, Brian, for the first thing, is certainty, and then producers' technology will solve the problem.
Yeah, to touch on the federal government, they have a framework for the methane reduction that they brought out, but they haven't actually implemented in. So there's a few companies that are trialing things out to see what that looks like for them on the balance sheet. And I think if there's just more certainty on when that was going to come out, or if it was going to come out, that would move things a lot quicker.
And have you been able to work with leaders in the industry that maybe with the uncertainty in the regulatory space or with the lack of clarity on honestly what future commodity prices are going to be, that no one has that answer? Why do they take these steps? Why are they leading? Why are they continuing to achieve these emission reductions if they don't have the same clarity from a business standpoint that this is actually something that needs to be completed?
In Western Canada, there is a methane equivalency tax. So you're seeing lots of the bigger midstream companies are actually getting a savings that's cost neutral for using our technology on their projects. So it is a step forward for them on that, but it's not across Canada.
The way we've been able to achieve it is producers have always been looking at operational efficiencies. They're continuously improving everything they're doing to reduce their costs due to labor issues, supply chain issues. So they're always looking ahead to how can we do things better, which, as I pointed out, if you're efficient, you're going to eliminate the emissions.
So in the space of trying to recognize what the opportunity is, we presented a number of different ways that we can tackle this. How does an organization take a look at this within their own operations and decide that this LSD needs this action, that one is good as it is, maybe I should do that LSD first? How would you see that a producer tackles this on scale if you've got hundreds of these sites that need to be improved, or perhaps even larger than that?
Most companies, I think, would do a little elephant hunting. So you just go to the sites that have the highest emissions and you start there, even if it's scattered. So generally speaking, you wind up with a fairly similar level of investment, regardless of the magnitude of the venting. So your biggest return is going to be on the sites that will have the greatest amount of venting. And then if you're making the decision purely on methane abatement, then that would be your target. If there's other things that are driving your decision, like operational efficiency gains, where your utility gas is unreliable and your instrumentation is being caved in by virtue of trash, then you could step to electrification really easily and address that. So not just the methane, but also operational efficiency gains. I'm assuming that's how most producers would make their decisions. But
so it's your opinion, Steve, that producers have a good understanding of their baseline, and it is site specific to know really which sites to be focused on as well?
There's a lot of pieces to the puzzle. Number one, operations has to buy into it. The accountants have to buy into it, and everybody has to buy into it. So I believe the first step is to try it. Try one. You don't need to worry about all of it till you're confident, until it fits in the way you want to operate, and then you can move forward. So I think it's just a matter of stepping out of your comfort zone a little bit, and whether you like it or not, reality wins eventually. So the sooner you have your toolbox full of solutions, it gives you an opportunity to meet the targets that you want.
Okay, so with trying it, is there, I know we just had the recent announcement as well for the methane reduction deployment program. So there's dollars that are being invested in commercially available solutions, maybe that are new to an organization. And there's also leading technologies that are maybe on the cusp of becoming commercially available too. How do you see that funding help in maybe the early adoption or in the small scale deployment before you would do a larger improvement in your operations?
It's critical to getting people's confidence in the technology. Programs by CRIN, by NGIF, by the ERA, everybody who helps people get over that hump of risk to try the technology and see where it fits in is key. And we've had some great success, NGIF and CRIN and, the ETC Center for Testing. I mean, we've been doing this for the last 5-10 years. So we're pretty proud of what we've been able to achieve, and we've proven it. And now it's a matter of adopting it.
I think it's just straightforward with the funding. It's going to allow them to actually financially be able to do it.
So do you see, though, that there's a barrier if it is 50-50 and we're able to reduce the cost by 50%, but you still have to cover the other 50%? Is that enough of an incentive?
I believe that is enough of an incentive. There needs to be some ownership on the companies themselves. 50% is quite a bit of money on a lot of these projects, so I think it's a great start anyway.
There's still the carbon tax that needs to be mitigated, and if the cost associated with the equipment that would be used to mitigate that expense is half as much, then the ROI looks much more attractive. So I agree. I mean, it is funding these projects to get them off the ground and get them moving.
Yeah, I think there's some variability in that context, but you're trying to reduce the cost of future operations. Like if there is a change in that future environment where the levy is reapplied on combusted emissions, for example, what does that mean again? And how do we make sure that we're not exposed to that?
The challenge I find is a company still has to come up with the other 50%. And if you happen to have a bank account that has the other half, that's fine. A lot of the smaller companies, I would like to see the program where taking the tax credits, audit them if they use the tax credits to update their technology. And that way it would benefit even the juniors. However, the program for 50% is fine. But if somebody gives me, for me to get $1 million, I got to come up with $1 million? That's tough.
Yeah, so while the funding is super helpful, it may not be the same enabler for every organization, and that's okay. That's just the reality of where everyone's at today. I do think I should highlight that the recent announced funding is stackable, and so there are opportunities where that could be stacked up to 100%. So there may be some avenues, even with other funding channels, where it doesn't actually need to cost you 50%, which is about as good as it can ever be, right? So that's pretty awesome. We've got about 5 minutes. Do you want to just kind of go through here? Maybe you've got some imparting thoughts or questions from the audience as well. Yeah.
What do you guys see as your low-hanging fruit for each of your businesses?
The low-hanging fruit, in order to reduce emissions, we need to hit the existing well sites. And that'll reduce the emissions. And that's our low-hanging fruit. We've had some major success in the new drill packages that the guys are going, because the regulations are in. They're already engineering and designing that. So that's been pretty easy, but there's still a lot of existing sites that are good low-hanging fruit for us to tackle at a very low cost.
I still think that there's a lot of pumps out there that could easily be replaced, and that would have a pretty significant impact on the amount of Alberta's carbon intensity. So, and then there's the instrumentation. I mean, you saw those two sections of that chart. Chemical injection pumps and pneumatics still represent a significant part of the overall amount of venting. So we can focus on those because they're going to be the lowest cost of the solutions. When we start talking about vent capture from tanks and stuff like that, it is dollar per ton. It's significantly greater. So that would be my call on it.
And then I would touch right back on and say the low-hanging fruit for us is the tank vents by destroying the gas. So there's different approaches you can do out there for your reductions. So picking the right technology for the right price is always there.
I think that the other thing is the quantification of the gas from the tanks. It could be a lot more gas than what we're talking about. I mean, I think people are still trying to figure it out. When you shoot a laser through a cloud of gas and it's like plus or minus 50%, that's hardly a you know, that's hardly an accurate measurement. So I mean, when we get to the point where we can legitimately and reasonably accurately totalize it, I mean, yeah, the tank venting could be a huge, huge thing.
Are there any last thoughts here before we close out the panel?
I got one.
In a succinct manner?
All right. So one of the things that I'd really like to see, and I think we would all like to see, is we're talking about going after export markets. Now, when I was in Brazil, I discovered that the duty for the green technology that I make is 50%. So, I mean, if environmental solutions are still considered an expense, and by virtue of tax, you're increasing the cost by 50%, it seems like a little support internationally from other governments for maybe having an international tariff code that if it's certified as being something that's genuinely environmental, how about a lower tariff?
Last thoughts, just try the technology, and with programs like CRIN, NGIF, ETC, we've got everything we need, and if the program still can carry on to help a lot of the producers, I think it's a great opportunity.
Yeah, just don't be afraid to try something. Lots of the time you might be pleasantly surprised how well it works and how little the cost actually is.
And I think we've been plugging away at this for a while, and it continues to be a journey we can stay on course to improve. So it takes, this ecosystem, this continued effort focused together. It's not a single company that can get this all done. So I appreciate that seems to be working really well. And I think that there's a lot more, again, that remains to be done in a very similar manner to how we've been tackling this previously. So thank you very much for your time. Appreciate, again, for the audience online joining us here today.